Hello viewers, welcome back to this course, and today we are going to start with the next lecture, that is lecture 18. So, today we are going to start with a new topic, and that is called Fourier series. So, this is the series has been given by the well famous French mathematician Fourier. So, in this so to start with the Fourier series, so first of all I would like to tell that we have the knowledge about the series, that what is the series. So, it is a summation of the terms we are taking, that for example, if I have a function, you must have seen the series of this type, x plus x square plus x cube, like this one. So, this is a series made up of polynomial. Similarly, we can have a series of trigonometric function like sin x plus sin 2x plus sin 3x and so on. So, this is a series, we call it the trigonometric series. So, in this case, so before that we start with the basics of the Fourier series. I want like to develop or discuss one concept, that is called the periodic function. Suppose I have a function f x and I say that this function is periodic and having period capital T, where T is finite. So, you can say that T is finite and greater than 0 if my function f x plus t is equal to f x. This is true for all x. So, then we say that this function f is a periodic function and it having the period capital T. Now, for example, I want to take a function. So, let us take a function f x is equal to the well known function I just take, that is sin x. So, in this case I know that the sin x plus 2 pi is again the sin x, and this is true for all x. So, in this case I can say that the sin has the is a period, is a function, periodic function and having the period 2 pi. Similarly, I can define the function, another function. I take the another function f x is equal to sin 2x or sin n x. So, in this case, if you see from here that from this one the period will becomes, so 2 pi by 2. So, in this case the period will be pi. So, in this case the period will be 2 pi by n. Now, 2 pi by n is the period of this function sin n x. Similarly, I have another function f x is equal to cos n x. So, we also know that the cos x plus 2 pi is also cos x. So, in this case we also know that this is a periodic function of period 2 pi, and from here also if I want to find out the period of this function, so it will be 2 pi by n. So, this is a well known function and we know that what is the period of this function. Now, I want to find out what is the period of function if I take f x is equal to some constant function 5. So, this is the function I have taken and I want to find the period of this function. So, if you see this one, what is the function here? So, this is a function and I define that x. So, suppose this is my 5 value and this is my f x, this is x. So, in this case if you see I take the value of x greater than equal to be 0, then this function is always 5. Now, from here I can say that function x plus t is equal to f x. So, what is the value of this t? But from here you can see that f x plus t is equal to f x, always true, because the right hand side is always 5 and left side is always 5, because this function is a constant function. So, if somebody asks me that what is the period of this function, then from here you can say that any real number, if I take t to be 1, t to be 2, t to be 0.1, t to be any value, if I take any real number, then I can say that this is a periodic function. So, from here I can say that for the constant function, any real number is a period of the function is equal to 5. So, in this case, see 0 is always there, capital T can be 0 also. So, that is true for everyone. So, in this case I am taking that including 0. So, real number, because the period T cannot be 0. So, from here I can say that whenever we define the period T, so in this case, because if you say that if I take T is equal to 0, then it is always true. So, we always go for T greater than 0. So, I am saying that the function, constant function has a period of any, so in this case T is equal to x, I can say, and x is greater than 0. So, this one I can take. So, any positive real number, positive real number. So, this is the period. So, this is the only period, only function, the constant function which has this type of property. Now, you also know that like I have a function is equal to sine nx, and my period capital T in this case is 2 pi by n. But if somebody asks me that it has a period 2 pi by n, what about its period as a 2 pi? Then we can say that 2 pi is also one of the period. So, I have this period, I have 2 pi period, I have 4 pi, all the periods are the period of this function. So, what is the period we generally take? So, we always take the minimum of all this one, that is called the period of the function. But if you see clearly that this is the minimum value, so this is the period, but 2 pi is also one of the period. So, for a one function we can have large number of period, but for defining the fundamental period we always go for the minimum value of that one. So, in this case I say that my period is this one for this function. Then so what the Fourier series says, so I will define with the Fourier series. So, in this case the first thing is that let my f x is a function, so it can be a piecewise continuous function in any interval where x belongs to from minus L to L, where L is a real number, and f x plus 2L is equal to f x. It means this function is a periodic function and it has the period 2L. Then I can write this function as a combination of a0 sin 0x plus a1 sin x. So, in this case I am taking a arbitrary period. So, I will define this as a series. So, I will just write the series as n is equal to from 0 to infinity a n cos n pi x by L plus b n sin n pi x by L. So, it is a trigonometric series, and we are, for the time being, we are saying that this series is convergent and it is convergent to the function f x, because when the series is convergent only then it can be written as a summation, can be written as a sum function. So, we are assuming that later on we will do this one, but at present we are assuming that this series is a convergent series and this series is convergent to the function f x, and where my x belongs to this interval. So, now from here I have this series. So, if you expand this series, so this, if I put n equal to 0 here, so this will be cos 0 is 1. So, I will get the value of a 1, and in this case if I put n equal to 0, this sin 0 is 0. So, b 0 is, it can be any value. So, from here I can say that it is a 1 if I put n equal to 0. So, only a 1 will left with, plus then I can have a 1 cos pi x by L plus b 1 sin pi x by L. So, this is the first term, then a 2 cos 2 pi x by L plus b 2 sin 2 pi x by L, and so on. So, similarly I can define all the terms of the series. So, from here I can write this series as a 1. So, this is the series, plus then I can put the summation n from 1 to infinity a n cos n pi x by L plus b n sin n pi x by L. So, I can write the series as in this form. From here it is starting from 1, because for n equal to 0 only we are left with the coefficient of the cos term. So, that is a 1, a 0, sorry, not a 1, a 0. So, my function is f x. Now, on the, if you see on the right hand side, this is a cos function, this is a sine function, and what is the period of this function? So, we can write from here. So, in this case I am considering my function having the period 2L. So, this function and this function, so I can divide by 2 pi over, it will be, because when it was nx my period was 2 pi by n. So, in this case I have n pi into L. So, this will be there. So, now if I, so this will be 2L by n. So, in this case I can say that my cos function has a period that is 2L by n. Similarly, from here I can say that it has a period that is 2L by n. So, this is all the functions, this function, all the functions has the period 2L by n, where depending on the n what is the value of n. So, I can say that, and I also told you that if 2L by n is the period of this function, that is a fundamental period basically, but 2L is also a period of this function, 2L also is the period of this function, and this is a constant function. So, I assume that it also has a period of 2L. So, from here if I see on the right hand side I have the combination of all the function, and each function has a period 2L, and the left hand side also I am assuming that the function has a period 2L. So, from here I can say that the function on the left side and the right side both are periodic function and having the period 2L. Now, the question comes here that this is my series and I know the value of cos and sine, but what about this coefficients? So, this coefficient how we can find out, because this series is not the exact series for the function f x unless we know the value of the coefficient, that what is the value of a 0, a n, b n's for all value of n. So, to start with this one, so I have my f x a 0 summation n from 1 to infinity a n cos n pi x by L plus b n sin n pi x by L. So, this is the series I am considering now. So, this I will call it 1, where x belongs to minus L to L. Now, so this from here, if you remember, then earlier we have discussed that the orthogonal property of the functions. So, here we will assume and we will take the help of the orthogonality properties of the function, that is cos and sine. So, from here if you see, I just want to find out what is the value of this function when I take sine n pi x by L into cos n pi x by L dx. If from here if you see that when L is pi, then this cos n pi x by L becomes cos nx. So, simply nx. So, whenever we are dealing with the period from minus pi to pi, then this expression becomes easier and it becomes only nx, otherwise it is n pi x. So, because we are doing it for any arbitrary interval. Now, for this one, and in this case I am taking the weight function, that weight function is assuming to be a 1 value. So, if you solve this value, then if you do the integration of this one, and then I just multiply by 2 and then the 2 sine n pi x by L into cos n pi x by L dx, then if I try to solve this integral and I am applying this inequality, that is a trigonometric inequality. So, I know that sine a plus b plus sine a minus b, that is equal to 2 times sine. So, this plus this by, so a plus b plus a minus b by 2. So, it will be a into cos this minus this by 2. So, it will be b. So, from here you can see that this one can be written as half minus L to L. So, this can be written as sine. So, this is n, I just take as m. So, because one I just take as m and one another I take as n, otherwise it will be always same, because what I am doing here that n can be 1, 2, 3. So, in this case I am taking sine is equal to so just I will write it as a sine m pi x by L, where n is also a integer and m is also integer, positive integer. So, this value is equal to m. So, from here I can write this as a sine m plus n pi x by L from this one plus sine m minus n pi x by L and then dx. And I am doing this integration from minus L to L of this function sine. And if you do this one, then if you do the integration, then you will see that the value of this function, if I put this after the limit, then this become equal to 0. So, in this case I can say that this is true, is always equal to 0 for all m and n. Even m is equal to n you take, in that case also its value will be 0. So, from here I can say that the sine function and the cos function with this argument with the weight function 1, taking the integral that integration from minus L to L follows the orthogonal property. So, from here I can say that the sine function and the cos function, they are orthogonal to each other. Also, I just want to define another that orthogonality. So, in this case now what I do is I just want to define about this function sin m pi x by L into sin n pi x by L dx. So, this one we want to find out. So, in this case if you do the same way the integration and putting the trigonometric equalities here, then you will see that this is equal to 0 when m is not equal to n, and then when m is equal to n its value is L. So, this integral you can do yourself. Similarly, if I want to define the another value, then you will see that minus L to L cos m pi x by L cos n pi x by L dx, again its value is 0 when m is not equal to n, and its value is L when m is equal to L. So, this orthogonality property is always satisfied, because when m is equal to n, then you will know that this become the square of that function, and then in fact this is the magnitude of the function, and that value is coming equal to L, otherwise this. So, this property is very important properties, that is the orthogonal property, because we are going to use this property to find out the coefficients in the Fourier series. So, now I start with this one. So, I have my function f x, and I have written that function as a 0 plus n from 1 to infinity a n cos n pi x by L plus b n sin n pi x by L. So, this is my series. Now, first I want to find the value of a naught, that how I am able to find the value of a naught. So, in this case what I do that, so this is the first I have taken, already I have given the name 1. Now, what I do that, integrate equation 1 with respect to x between the limit minus L to plus L, and I integrate this one. So, I have, and this integration I am taking term by term integration. So, minus L to L I have f x dx, and on the right hand side I have a 0 plus then the summation n from 1 to infinity. So, this is a integration minus L to L a n cos n pi x by L dx plus integration from minus L to L b n sin n pi x by L integration this one with respect to x. Now, from here if you see this integration, so if you see from here that cos n pi x by L I am taking, and I am integrating from minus L to L, in which this function is has the period 2L. So, if you see from here, if I take the integration, a n is a constant, so the integration of this cos will be sine, and I am putting the sign of the value after putting the limit, I am putting the value of L. So, L will cancel out, I will get only n pi. So, sin n pi is always 0. Similarly, minus L sin n pi will always 0. So, if you see this one, this will be always 0. Similarly, similar case is here. It is a odd function, and I am doing the integration of this odd function in the interval minus L to L. So, if you do the integration, this is also coming 0. So, from here I can write from here that this will be equal to minus L to L f x dx, and then a naught I can take common, and this will be equal to 2L, because I just do the integration x and putting the limit plus everything is 0. So, from here I can find my value of A naught. So, this is equal to 2L from minus L to L f x dx. So, this is the value I am able to find for the coefficient, that is A0, and if you see it clearly, what I am doing is that I am taking the function, integrating that function from minus L to L, and you know that the integration gives you the area. So, this is the integration area and divided by the length. So, this is, I can say that the average of the function. The function f x over the interval minus L to L. So, it gives the average value of the function, because if you see that the summation becomes the integration in the form of the function. So, this is basically this, I am taking the sum of the function over the values divided by the total, the length of that value. Since, so this case become the average value of the function. So, by this way I am able to find the value of A0. Now, after finding this value, I want to find the value of all these ANs and these BNs. So, first I want, suppose I want to find the value of A1. So, let us I write the function f x. Now, I write A1 cos n is 1. So, n pi x by L plus A2 cos 2 pi x by L and so on, plus B1 sin pi x by L plus B2 sin 2 pi x by L and so on. So, suppose I want to find the value of A1. So, what I do that, I will multiply. So, this I just give it name 2. So, what I do that in this case with the value of A1. So, I multiply this with the cos. So, this is a cos pi x by L. So, I multiply it by the cos pi x by L, or accept the cos pi x by L. So, I multiply this by cos 2 pi x by L. So, what I do that, I multiply this function by, let us do this one, and minus L to L dx is equal to A0 cos 2 pi x by L minus L to L dx plus A1 I want to find minus L to L cos pi x by L cos 2 pi x by L dx and so on. Now, I just told you that cos 2 pi x by L, if I integrate it become the sine and then putting this value. So, using the integration I can verify that this value is equal to 0. This value depend upon the function, what is the value of the function. So, this integral will remain like this one. What about this one? So, in this case I have cos, so n, if you say this is a 1, and I know that just now we have done that these functions cos m pi x and cos n pi x, they satisfy the orthogonal property. So, this value will be 0 in all the cases, except if I multiply this by the cos pi x. Suppose I multiply this whole series, the 2 with the cos. So, with the cos 2 pi x, you know that everything will be 0, except I will get here from A2. So, I am just finding the value of A2, just, so this is A2 cos. So, I just want to find the value of A1. What I will do is, I will pre-multiply multiply this function by the same factor as cos pi x by L in this case. So, I will not multiply by 2, I will multiply the cos pi x by L, cos pi x by L, and then here also. So, this is, now I am multiplying by the same factor cos pi x by L. I just wanted to show you that if I multiply by some other factor, only the coefficient of that factor will remain non-zero, otherwise it will be 0. So, now in this case this is 0, this is 0 and this is the remaining, and now this value is not will be 0, because what it is doing now, it become the minus L to L square pi x by L dx, and this is what we know that it is the magnitude of the function. So, this value I just told you that this will be equal to L. Then the other integral becomes 0, because only in this integral I have the cos pi x by L multiplied by cos pi x by L. Otherwise, next will be cos 2 pi x by L into cos pi x by L. So, in that case this value integral value will be 0. Sin pi x by L multiplied by cos pi x by L, and we know that by the orthogonal property this integral will be 0. So, all the integral will become 0, only I will left with only the coefficient a1 and this integral value will be L. So, from here I can say that my a1 will be, so this will be 0 and this is L. So, I just take the L here and minus L to L, I will write it as a f x cos pi x by L dx. So, I will come up with only a1 here. So, now I doing the same property for other coefficient. So, now what I do is that I have my series, the Fourier series whatever we have written. So, to find, now I will try to find the value of the a n for all value of n. For n is equal to 0 is already there. So, 1, 2, 3 for all n I want to find the value of a n. So, what I do now, I multiply the equation number 2 with the, so I have my f x a 0 plus sin n pi x by L. Okay. So, now what I do is that, so this is we have started with 1. So, I just now it was my first equation. Now, I multiply equation number 1 with function cos m pi x by L, okay, and integrate with respect to x. Multiply the equation number 2, integrate with respect to x between the limit minus L to plus L. So, in this interval I will want to integrate. So, from here I will get my f x cos m pi x by L minus L to plus L dx is equal to minus L to L a 0 plus summation a n integration minus L to L cos m pi x by L cos n pi x by L dx plus b n minus L to L cos m pi x by L sin n pi x by L dx. So, this integration is there. Now, I know that this will be 0, this sin and cos this will be 0 for all value of n and m. Only thing is that this integration we know that this is equal to, so this is equal to 0 when m is not equal to n and equal to L when m is equal to L. So, from here I can write that minus L to L f x cos n pi x by L dx, because now I am considering m is equal to n. So, instead of m I am putting n is equal to this 0, everything will be 0. When m is equal to n, I am left with only coefficient, that will be a n. So, it will be a n into L, other things will be 0. So, from here my a n I can write as a 1 over L from minus L to L f x cos n pi x by L dx. So, this is my the coefficient a n, and this is true for all n except 0, because for the 0 we have found the different means separately, that for the a 0, but otherwise for n is equal to 1, 2, 3. So, this is the formula for that one. Similarly, I can find the value b n multiplying by the sin n pi x by. So, if you do the same way, then you will see that my b n in this case will be f x sin n pi x by L dx. So, this is the coefficient I am able to find for the sine function. So, after doing this one, so now from here I can say that I have the function f x, which is a periodic function in the and having the period 2L. So, this can be written as a series a naught plus summation n from 1 to infinity a n cos n pi x by L plus b n sin n pi x by L, where my a 0 is just the average value of the function doing the integration. So, here x belongs to minus L to L. And then if I want to apply this function for the whole period, then the same function will vary. So, f a naught is this one dx, a n is 1 over L my f x cos n pi x by L dx, and my b n is 1 over L minus L to L f x sin n pi x by L dx. So, based on this one, so I am now able to write the Fourier series as a whole, and we are able to find its coefficients. So, it depends on the function, that which function you are taking, we will do this integration, and then we should be able to get the Fourier series. So, let us do one example. So, we will take the example that is a very simple example, just want to take. So, take example number 1, and we start with the example 1 as just now I take function my f x is equal to x, and my x belongs to minus pi to pi. So, this I am taking, but if you see that my function, and if I plot this function is this function. So, this is my x axis and y axis, and if you take this function as a pi, and this is minus pi. So, this is a straight line. So, this is my function. So, this is a function f x is equal to x, and if you see that this function is well defined in between minus pi to pi, and from here looking at this graph we cannot say that this function is a periodic function, because nothing, it is defined only in this value from minus pi to pi. So, to make it periodic, what I do is that I apply the condition that f x plus 2 pi is equal to f x. So, this one I have to put this condition. So, based on this condition, now only I can say that this function f x is a periodic function and having the period 2 pi. So, from here if the function is of having the period 2 pi, then I want to find the Fourier series for this function. So, basically I want to find my Fourier series, that is f x is equal to x is equal to a 0 a n. Now, in this case my L is pi. So, I know that this becomes cos n x plus b n sin n x. Now, I want to find the value of my a 0. So, a 0 I already know, then this is equal to 2 L. So, L is, in this case L is equal to pi. So, this would be 2 pi from minus pi to pi x dx. So, this value will come. Now, from here if you see this function is odd function. So, if I integrate from minus pi to pi, the area under this and the area under this are similar, but of different sign. So, this value if you do the integration, this will be 0, because this is odd function. Now, I want to find the value of a n. This one you can do very easily, that because it will be 1 over 2 pi and this is a x square by 2 from minus pi to pi, and then it will be 1 over 4 pi, it will be pi square minus pi square. So, this will be 0. Now, I want to find the a n. So, a n will be 1 over L. So, L is pi from minus pi to pi. Now, f x is x into cos n x dx. So, using this one I want to find the value of a n. Now, my function x is, you know that x is a odd function here. So, x I can say that this function is an odd function, and the cos function I know that is an even function. So, if I look at this one, I am having a function, a odd function multiplied by the even function. So, it is just, you can say that if you remember that odd number multiplied by the even number. So, result should be the odd, and then its value should be equal to 0. So, this one also we can check, because I am from here I am multiply by odd function multiply by even function. So, this is equal to odd function. So, if I do the integration, its value should be equal to 0. So, but only we are using the property of the odd function and the even function. Then I want to find the value of b n. So, if you see the b n, this is 1 over pi sin n x dx. So, this is the odd function, this is the sine also, we know that this is odd function. So, multiply by odd into odd becomes the even. Then I want to solve this one integration. So, this will be equal to 1 over pi, and then I will apply the by parts rule. So, this will be x. So, sine integration will be minus cos n x by n. So, this is the limit from minus pi to pi minus pi to pi, and x, the derivative of x is 1. So, it will be minus cos n x by n dx. So, we will get from here, and then from here, so I will just write here, using from here I will get 2 over pi 0 to pi. And from there if I go by this one, so in coming 0, and this is 0 and this is 2. Now, this value will be not be coming 0. So, if you do the integration and putting the limit now, so this value comes here 2 by pi, and then 2 by pi minus pi cos n pi divided by n. So, this value will come, and after doing this one I will get this pi will cancel out with his. So, I will get 2 by n and then cos minus. So, this will be minus n plus 1 because cos n pi when n is equal to 1, cos pi is minus 1, when n is equal to the cos 2 pi is 1. So, depending upon the value of n, the value will be either minus 1 or 1, and minus sign is already there. So, I am taking minus 1 raised to power n plus 1. So, this is the value of my Bn. Okay. Be careful that here we have used the property of the even function, and then we have changed the integral into this form 2 by pi from 0 to pi, and then we do the integration. So, from here I can write my function now. So, my function f x is equal to x, it can be written as, so a0 was 0, a n was 0. So, I get only b n. So, b n is this one. So, from here I can write n from 1 to infinity 2 by n minus 1 power n plus 1 into sin n x. So, this is my Fourier series for the function x, which is, we assume that it is a periodic function from minus pi to pi and having the period 2 pi. So, this is the Fourier series. If you expand this one, I can write this series as when n is equal to 1, it becomes positive. So, it will be 2 sin x. Then when n is equal to 2, so in that case this will be minus. So, minus 2 by 2 sin 2x. Then 3, it will be 2 by 3 sin 3x minus 2 by 4 sin 4x, and so on. So, from here you can see that on the left hand side I function as a, so this function an algebraic function that is equal to x. So, this x is being approximated by the summation of the trigonometric. So, on the right hand side we have trigonometric function, and on the left side I have a polynomial or algebraic form, that is x. So, that is, we call it the Fourier series or the approximation of the function x with the trigonometric function. So, it is all about that how the Fourier series we can define for a function when the function is a periodic function and having a period either 2l or 2 pi. So, in the next class we will go further. Thanks for watching.